Hey, Mr. Bruns here. I'm going to talk today about solving a pattern. Um, so if you don't have your math notebook out right now, you're going to need that. So go ahead and pause the video and get your math notebook out and a pencil. And once you have your math notebook, again, go ahead, pause the video and copy down what I have here, what we're working on. And when we're talking about solving a pattern, we're looking to find the change and put together an equation that we can use to figure out what the pattern is going to look like farther down in the future. All right, now that you've got everything copied down, we're going to use a table first of all. This is the simplest way to kind of track what's going on in our pattern and look at it and do some deeper analysis. Okay, so the first thing we're going to do is look at figure 0. And of course, we've just got one block there. And then looking at the change that's happening between 0 and 1, it looks like we're adding a block to each side and then one on top. So we've got one on each side, 1, 2, 3, 4, and then one on top is 5. So 1 plus the 5 is 6. And we're adding 5 to that, right? And then looking at the next figure, we're going to do that again. We're going to add 1 to each side, 1 in the back, 2, 3, 4, and then 5 on top. 1 plus 5 on top is 11. Okay, so thinking about the next blocks, right? Like what figure 3 would look like. We're probably going to add 1 here, 2, 3, 4, and then 1 on top, 5 plus 5 gives us 16. Again, add 5 again. The fourth figure is going to have 21. And the fifth figure, add 5 again, 26. Okay, so now we know what our change is. We see that each time we're adding 5. So since the difference between each consecutive pair, each two figures, the difference is 5. We're adding 5. So our change is positive 5, adding 5 each time. All right, so let's start to talk about the equation here. So we're going to look for some sort of an equation where we have the number of blocks. It's going to look like something like this. The number of blocks equals, and then some sort of a computation. Okay. So when we look at our figures, for figure number 1, we've got the original, and then we add 5 one time, right? So then for figure number 2, and that makes sense, right? We've got that 1 in the middle, and then we've got plus 5, plus 1 block on each side. All right, now if we look at figure 2, we've still got that 1 block in the middle, but this time we're adding 2 to each side, right? 1 plus 2 on each side, so 2 times 5. And then for figure 3, we will have that 1 in the middle and then plus 3 on each of these legs here, right? 1 plus 3 on each side. So using that pattern, I can kind of say, well, for whatever figure number, let's say figure 10, for example, I'll have for figure 10, right? I'll have that original 1, and then I'll have 10 on each side. 1, 2, 3, 4, 5. So 10 times 5. And there's a number of different ways you can kind of think about this, right? You can say like, well, I have my original 1, and then I add 5 to get figure 1, and then I add 5 again to do figure 2, and then this 5 plus 5 is really 2 times 5, right? And then for figure 3, same thing. It's that original 1 plus 5 to get to figure 1, plus 5 again to get to figure 2, plus 5 again to get to this figure. So we're adding 5 3 times, right? Or you can look at the legs and say, okay, each leg is, in this case, the legs are 2 for figure 2. For number 10, the legs are going to be 10, right? There's a number of different ways that you can kind of figure this out. But you want to get to, a computation that makes sense for you. All right, so we've got a bigger number 10, 1 plus 10 times 5 legs, each are 10. So for any number figure, we're going to say all the way down, we've got for any number, any figure number, we're going to have that 1 plus, 5 legs. And then each of those legs is going to be 10 long, 5 times whatever that figure number is. Oops, I'm going to write this a little clearer. 1 plus 5 legs, and each of those legs are going to be n blocks wide. So 1 plus 5 times n. All right, so there we go. 1, the original 1 plus 5 times n. So it's always a good idea to verify your equation too. So I'm going to take this and I'm going to test. I'm going to test it out on a value that I already know. We've already counted all the way up to figure 5 is supposed to be 26. All right, so let's go ahead and test that. 5. All right, so it should be using our equation 1, the original 1, adding 5. And then whatever n is, whatever the figure number is, we're going to plug that in for n, okay? And that gives us 1 plus 25 equals 26. So we've just verified that our equation works with a value that we already know. So we can be pretty confident in that.